Welcome to this session on permutation and combinations. This is the second session on questions based on digits. So let us look at another question. How many 4-digit numbers can be made from the digits 0 to 9? So this question is identical to the question that we saw in session 1 on problems of digits. And once again, I draw a partition. On the right side, we will mention all the constraints. So there we have all the constraints, and on the left we will actually solve the question. So what are the constraints here? The constraints here is one, the number of digits can be 0 to 9 only, and since it's a decimal number system, you would be hardly surprised by that. Then the other constraint is that we are looking for a 4-digit number. So let us now try to solve the question. So we will arrange, we have the 4-digit numbers, and how many tasks are required? Obviously the number of tasks are 4. And what are these tasks? The tasks are placing one digit at each of these places: the units place, the tens place, the hundreds place, and the thousandth place. Once again, we start with the thousandth place. And why do we have to start with the thousandth place? Only because one of the digits from 0 to 9, that is 0, cannot be placed at the thousandth place, because we are looking for a 4-digit number, and a 4-digit number at the thousandth place cannot have 0. So how many choices of digits exist to fill up this thousandth place? All the digits from 1 to 9. So there are 9 choices to fill up the thousandth place. Now because repetition is allowed, how many choices for the hundredth place? Once again, we have 10 choices for the hundredth place, we have 10 choices for the tens place, and we have 10 choices for the units place. And because all the 4 tasks have to be done, therefore we will multiply 9 into 10 into 10 into 10. That will give you 9,000. So obviously there are 9,000 4-digit numbers that can be made. What would have been the answer if in the same question repetition were not allowed? If repetition were not allowed, then repetition not allowed. So if repetition is not allowed, then out of these 10 digits, we can fill the thousandth digit once again in 9 ways. Now because one digit has already occupied the thousandth place, we can fill the hundredth place again by 9 digits. Because there are 10 digits in all, one of the digits has occupied the thousandth place, and therefore for this particular place we have only 9 digits remaining. Now how many digits remain for the tens place? Out of 10, 2 have already been occupied. Repetition is not allowed. Therefore we have 8 choices for the tens place. How many choices for the units place? By the same logic, we have 7 choices for the units place. And because all the 4 places have to be filled, the total number of choices will be 9 into 9 into 8 into 7. That is 4536. Let us solve another question. How many 4-digit numbers can be made from the digits 0 to 6? Part A, repetition of digits is allowed, and part B, repetition of digits is not allowed. Once again, I have drawn a partition. To the right of the partition, we will talk about our constraints. Now in this question, what are our major constraints? The first constraint is number of digits. So how many digits are permissible for us? Only the digits from 0 to 6. So these will be a total of 7 digits. What is the second constraint? The second constraint is that we have a 4-digit number. So we will have to fill 4 places: units, tens, hundreds and thousand. Let us start filling up these places. So how many tasks are required? Number of tasks are 4. And which are these 4 tasks? Filling the units, the tens, the hundreds and the thousand place in this case. So now how many digits can fill up the thousandth place? Since we have a total of 7 digits, out of which one of the digits is 0, the thousandth place can be occupied only by 6 digits, from 1 to 6. 0 cannot be placed in the thousandth place because it does not carry any value then. How many digits will occupy the hundredths place? Because repetition is allowed, all the 7 digits can be placed at all the 3 hundreds, the tens and the units place. So we have 7 digits possible in the hundreds place, we have similarly 7 digits possible in the tens place, and we have 7 digits possible in the units place. So what does that yield? Because all the 4 jobs are compulsory, therefore the total number of numbers that can be formed in this way are 2058 numbers. Next, let us look at part B. In part B, repetition of digits is not allowed. So therefore, how many digits will be placed on each of the places? Let's see that first. And now, to solve this part B, we have another constraint added on, and that is repetition is not allowed. So repetition not allowed. So how many digits can be placed in the thousandth place? In the thousandth place, we can place all the digits except 0. So we can place a total of 6 digits in the thousandth place, and which means that we have used up one of the available 7 digits. So how many digits are balanced? Balance number of digits are 6, and we can fill up the hundreds place with any of the 6 digits. Similarly, the number of digits balanced now is only 5, and hence at the tens place we can have 5 digits possible, and similarly at the units place we can have only 4 digits possible. And because all these 4 tasks, placing digits at the thousandth, at the hundredth, at the tens and at the units place are mandatory, therefore we will multiply 6 into 6 into 5 into 4, that will give us 720 numbers. So this was a similar question, except that we had limits on the number of digits and we could only use up digits from 0 to 6. So with this we come to an end of this particular session of circles. If you wish to watch more videos or if you wish to know more about the topic, please log on to our website pfindia.com. If you want to ask a doubt, please write to us at studentservices@pfindia.com. And if you're watching this video on our website, please use the Ask a Doubt feature. Thank you very much.